Okay, so I'm going to talk today about why we built our workload identity platform based on SPIFFE and SPIRE. I'm Tyler Julian, and if you guys don't know me, I am a software engineer at Uber. I work on our identity access management teams building security infrastructure. When it comes to SPIRE, I'm a maintainer on the project. I've been working on it for the last year or so. And so what I want to talk to you about in this presentation is the why behind why we chose SPIFFE and SPIRE, what led us to this decision, what were the sort of like business requirements around SPIFFE and SPIRE. So a little background on Uber's infrastructure. We have deployments in both cloud and on-prem data centers, our own hardware. We do RPCs with gRPC, HTTP. We even have an in-house protocol called T-channel. That's a lightweight framing protocol on top of TCP. Orchestration, we actually use Mesos, Hadoop, and some other in-house tooling. So while we're not using Kubernetes proper, we can take a lot of benefit out of the cloud-native approach. We have services written in Go, Java, Python, Node, pretty much everything under the sun. So we have this very kind of like fractal infrastructure story, and if we want to solve identity, we need something that's going to work everywhere. So the benefits of workload identity, the goal first off is to be able to uniquely identify a particular program or application. This allows you to control access to database credentials, third-party API keys, and even access to other internal services. This allows you to protect your data using encryption in transit, TLS, that kind of thing, and control access to databases. So why would you want this? First and foremost, if you are subject to any compliance requirements like GDPR, SOX for public companies, and HIPAA, actually having a really controlled access story is really important so that you know what's accessing your financial data, what's accessing your health data, what's accessing your user data in the EU, in the case of GDPR. And from a trust and security standpoint, this is just going to help you reduce the assumptions you have on your system behavior. You know which services are actually talking to which services. It helps prevent misconfigurations and reduce the risk of unauthorized access. So I want to tell a bit of a story around authentication, what it looks like in a microservices architecture, and how your system might evolve over time to really need this type of thing. So in the early days of your architecture, say you're a hypothetical ride-sharing business and you have a user's database and you have three services that want to talk to get user information, right? You have a matching service that matches riders and drivers. You've got a trip service that tracks the state of a trip. And you've got a payment service. And all these things need access to the database. So how do they get that? Well, you might use a username and password. That seems like a reasonable approach. And then you have to decide, as you start to add more services, do you share the same credentials between all these services, or do you use a different credential for each service? And now you have to make this decision. Am I going to make it easy to spin up new services because I'm reusing this credential all the time? Or am I going to sacrifice that auditability and actually instead use a unique username and password for each service? So this is a decision that you would have to reasonably make. But what you start to see is that as you start to scale this out and add more and more services, a credential per service doesn't scale that well. And if you're sharing the credential among all the services, now you have this auditability problem. You have people writing garbage queries, and it's all coming from the same user. So like, how do you actually know who's writing these queries? And so you come up with the idea to create an API gateway that sits in front of your database. Now you've solved this problem. You know exactly where you can actually start to filter these queries as they come in, and you've removed this credential management problem because you only need one credential between the API gateway and the user database. But now you have a new problem, which is how do all these services authenticate to the gateway? And so, you're growing at a very fast rate. You don't have time to think about things like public keys. So you might use a name tag approach for identity where a service just announces, I am the matching service, I am the trip service. And that's how you authenticate. And maybe that's fine kind of in the beginning because you have a secure perimeter and you know that inside your secure perimeter, you trust everything that runs there. But as we've started to see over time, the idea of a secure perimeter, it starts to disappear, especially at these really large companies where threats come from outside but also from within. And so later on in the stage of your company, say you want to migrate from this API gateway to a V2 that's in the cloud, you have to start thinking about how do we actually move these services over, and you're tracking to make sure that this migration is happening. And then you start to realize that, wait, we still have the payment service calling the old API gateway, but the payment service already switched over. We have somebody copied and pasted some code, and this thing is just running as a cron job. I mean, who knows? And so what secure workload identity allows you to do with something like Spire is to actually lock down these things, not use that name tag approach anymore, but actually use secure cryptographic identity to solve this kind of problem that you see when you start to scale up lots and lots of microservices. So Spire is a piece of software that will then issue these kinds of secure identities, SPIFFE being the specification that it's built on. And so that's kind of the long and the short of how we got to where we are today, and why we decided to use SPIFFE and SPIRE. So thank you guys very much for listening.